Okay. So our today's class topic is basically gradient of a function. What is gradient of a function? And using gradient, we have a Lagrange multiplier process to find an extreme values of a function that is called the constrained extreme values of any function. Okay, so our first topic is basically gradient. This is very known to all of you.
স্যার বাইরের অনেক সাউন্ড মানে আপনার কথার সাথে অনেক করতেছে।
ওকে, সো আমি এটাকে ফিক্স করার ট্রাই করতেছি। Okay, so is it okay now?
নো স্যার।
ওকে, সো আপনারা কি এখনো কি কোনো সাইড সাউন্ড শুনতে পাচ্ছেন?
স্যার মোটামুটি তো ক্লিয়ারই আছে।
আচ্ছা,
একটু ভালো হয়েছে আগে থেকে।
স্যার অত সাউন্ড শোনা যায় না।
ওকে, আমার এন্ড থেকে আই এম সরি যে যদি কোনো ধরনের ডিফিকাল্টিস হয়। আই থিংক এখন ঠিক হওয়ার কথা।
জি স্যার ঠিক আছে স্যার।
বেটার স্যার।
Okay, thank you. So our topic is basically first topic is gradient. So this is basically known to all of us. Let's say we have a function f of x comma y. Okay. So gradient of this function is del f del f divided by del x with vector I, del f divided by del y with vector j, okay, since this vector is two-dimensional, so we need not to write the third dimension. Okay, so for example, we have a function in two variable fxy is equal to x square y cube. So gradient of this function at any point x comma y is equal to, just need to differentiate this function with respect to x, and differentiating this function with respect to is twice x times y cube I plus differentiating with respect to y is 3x square y square j cap. So gradient for any three variable function, if a function is a three variable function x, y, z, then gradient of this function is just fxi fyj and fjk. So this I comma j comma k, these are the unit vector in the direction of x, y, and z axis.
স্যার আপনি কি মিটিংটা রেকর্ড করছেন?
Yes, আমি মিটিংটা রেকর্ড করতেছি। Okay, so for any three variable function, let's say we have a function in three variable, x square, y square, z to the power 5. So gradient for this function is just differentiating with respect to x and just need to multiply with unit vector in the direction of I. So this is 2x y square z to the power 5I plus twice y x square z to the power 5 z and 5z to the power 4 k cap. So this is a basically this is a transformation from any scalar function to the vector format. I think আপনাদের মধ্যে কেউ বলছেন যে এখনো ক্র্যাক করতেছে। যদি বেশি প্রবলেম হয় তাহলে আমরা মনে হয় ক্লাস কন্টিনিউ করব না, যদি প্রবলেম না হয় তাহলে আমরা ক্লাসটা কন্টিনিউ করবো আর কি। সো আমাকে একটু জানান, ইফ দ্য প্রবলেম ইজ এক্সট্রিম দেন আই উইল try
না
to
স্যার,
take
শোনা
this
যাচ্ছে,
class in any
সমস্যা
other
হচ্ছে না।
case.
স্যার আপনার ভয়েস ক্লিয়ার।
ওকে, থ্যাংক ইউ। সো কেউ মনে হয় বলতেছেন যে আমার ভয়েসে একটু প্রবলেম হচ্ছে, একটু দেখবেন আর কি যে আপনাদের এন্ড থেকে কোনো ধরনের প্রবলেম আছে কিনা। Okay, so now why we need to introduce this gradient? This is because of for Lagrange multiplier process we need to use the concept of the gradient. So why Lagrange multiplier is needed? So first of all, consider we have a rope. We have a cord of length 20 meter. So this is a rope or cord. Okay, the question is how many area we can how many maximum area we can
x square y square
স্যার
z to the power 4 হবে না?
স্যার ওখানে তো
yes,
এক্স এন্ড
so
ওয়াই টার্মটা স্যার আপনি দেন নাই স্যার, ওখানে কি হবে না এটা
yes, so
এর
this
সাথে?
is x square y square times k vector. Yes, I have made a mistake. So idea of constrained relative extremum problem. So just I am explaining the idea of constrained relative extremum problem. Constrained extrema values. Okay, so for example, consider we have a rope of length 20 meter. Now the question is how many rectangular area we can form taking this rope as a okay, so how many rectangular area we can form using this rope as a perimeter of a rectangle. So in that case we can consider, okay, let's say length is 6, breadth is 4, then the total area of this rectangle is basically 6 times 4 is equal to 24. So another choice can be, okay, length is okay, so another choice is, okay, length is something 7 and width is 3, so 7 3 7 3. So
Sir,
the
can you
area
show the
of the,
first page again?
yes,
স্যার কোয়েশ্চেনটা কি ছিল?
So idea is basically we have a rope of 20 meter and how many area we can generate taking this as an rectangular form. So the choices can be 6, 4, 7, 3, 8, 2, 5, 5, 4, 6, and many more combinations. But we need to maximize this area where the perimeter is something 20. So in this case, we can see area is 7 times 3 is equal to 21. So basically, we need to maximize the area under a constraint, and that constraint is perimeter must not be greater than or less than or equal to 20. So basically, we need to maximize this area. Let's consider the length of the area is x and the width is y, and our target is to the maximize this function fxy, and function is basically area of this rectangle is x times y, but we have a restriction, and that restriction is the perimeter of this rectangle must be 20. So that is twice x plus twice y is equal to 20. So this is also a maximization of a function, but under a constraint, that is under a restriction. In this case, the restriction is the summation of x and y must be 10, and under this constraint, we need to maximize the function f of x comma y is equal to xy. So for maximizing this function, we have a process. That process is called the Lagrange multiplier. So question is maximize function f of x comma y is equal to xy under the constraint or restriction. What is the constraint? In this case, the constraint is twice x plus twice y is equal to 20. So we can write this is something x plus y equal to 20. For using the Lagrange multiplier process, we need to write the restriction in this way, which is just x plus y minus
Sir,
20 is equal
how
to 0.
did we get twice x plus twice y from xy?
Okay,
10 হবে না?
sorry, 10 হবে, yes. Okay,
Yes,
yes.
sir.
In this case, the perimeter is we have two length and two width of a rectangle, and the total quantity is 20. So twice equal to 20. If we take common 2 from the both sides, then x plus y is equal to 10. So this is the restriction. The values of x plus y minus 2 minus 10 must be 0, and need to maximize this function f of xy is equal to xy. Okay, so yes.
স্যার কি থিওরিটা পড়ছি একটু আবার একটু বলবেন, রিপিট করবেন?
Yes. So আমরা basically যেটা থেকে পড়তেছি সেটা হচ্ছে section number 13.9. This is section number 13.9 from our Howard and Ton books, and the topic is Lagrange multipliers method, which is basically calculating the extreme values of any function when there is at least one or two constraint on that function. So we have one restriction, and within that restriction we need to find the maximum value of function, and that is called the constraint extremum value of any function. So this is the question. We want to maximize this function. In this case, our function is just x comma y, x times y, and the restriction is we can write it just x plus y is equal to 10. So just write this constraint this way: z of x comma y is equal to 0. So g of x comma y is equal to 0 means this is clear. In this case, our g of x comma y function is x plus y minus 10. So what is the Lagrange multiplier now? So Lagrange multiplier is this is theorem number 13.9.3. So I think this is visible, right? Section number 13.9.3, constrained extremum principle for two variables and one constraint. Can you see the Howard Hunton books on your screen? Yes, sir. Can you? আপনারা কি স্ক্রিনে হাওয়ার্ড হ্যান্টনের বইটা দেখতে পাচ্ছেন? সেকশন নাম্বার 13.9.
Yes, sir.
Yes, sir, it is
So this is
visible.
called the constrained extreme principle for two variable function and one constraint. That is, we have a function f and one restriction g. So if has a just one second. Okay, if f has a constrained relative extremum, then this extremum occurs at a point x0, y0 on the constraint curve, at which the gradient vectors, gradient of f and the gradient of restrictions are parallel. So basically, at the point where f of x comma y function has a extreme values under the constraint z of x comma y, at that point gradient of f is parallel to gradient of z. So gradient of f is a vector and gradient of z is also another vector. So these two vector is parallel, but we don't know the magnitude of these two vector, whether this is equal or not. So if we want to equate these two function, these two vector, gradient of f equal to gradient of z with a multiplicity, let's say lambda. So we know these two vectors is parallel, but not necessarily the magnitude of those vectors are equal. So since this is not a confirm that okay magnitude are equal, so that's why for writing the equal of these two vectors, we need to multiply a lambda quantity with any of these two gradients. If the magnitude is also the magnitudes are also the same for the both vectors, in that case lambda quantity is basically 1. So according to this theorem 13.9.8, if a function fx comma y has an extremum value under the constant g of x comma y, and at that extremum point the gradient of f must be parallel to the gradient of z, so we can write this condition: gradient of f is equal to lambda times gradient of z. So this is called the Lagrange multiplier process. This lambda is called the Lagrange quantity. This is basically Lagrange multiplier. Lagrange multiplier. Okay, so our function was in this case f of x comma y is equal to xy, and our constant was x plus y minus 10. So just need to calculate the gradient of both function. So f of x comma y is xy, and gradient of this
থিওরেমটা
f,
আরেকবার বুঝাই দেবেন?
sure. Okay, so theorem is basically a constraint extremum principle for two variable and one constraint. So basically we have one constraint, and under that constraint we need to maximize that function or minimize that function. That means need to find the extremum value of that function. Okay, if f has a extremum a constraint relative extremum, then this extremum occurs at a point on the constant curve at which the gradient vectors gradient of f and gradient of z are parallel. That is, there is some number lambda such that gradient of z is exactly equal to the lambda times gradient of f. Sorry, gradient of f is equal to lambda times gradient of z. So basically, the theorem says so we have a function fx comma y, and we have a restriction constraint gx comma y. This function fx comma y has a relative has a extremum quantity under this restriction if gradient of f is parallel to gradient of this constraint g. So basically gradient of f is a vector because of after calculating the gradient. So basically we are converting a constant function into the vector that is called the gradient quantity, and gradient of z is again a vector quantity. So these two vectors is parallel. So we have one condition, these two vectors are parallel, but not necessarily the magnitude of those vectors are equal. So let's say this is gradient of f and this one is gradient of g. Gradient of f is let's say 2 unit length, and gradient of the length of the gradient of z is let's say 1 unit. So two vectors are equal when their magnitude and the directions are both equal. So in this case, since two vectors are parallel, so this is obvious the directions are same. But what about the magnitude of these two vectors? So for the magnitude, maybe magnitude of these two vectors different. So that's why in this case, for this particular example, del f is equal to exactly 2 times gradient of z, that is del of z, because of the length of this del f is 2 and length of del z is 1. So for equating these two quantities, definitely del f is equal to 2 times del z. So according to theorem, this is just known. Gradient of f is exactly parallel to the gradient of z. So for writing this equation, we need to multiply at least one quantity by equating the magnitude also. Since this is since theorem says these two vectors are parallel, and by this equation we can write, okay, now we can say these two vectors as well as parallel and the magnitude of these two quantities are basically same. We will fix the lambda quantity according to the magnitude of del f and the magnitude of del g. If the two vectors are same, the length of these two vectors basically same, so gradient of f is equal to gradient of z. In that case, our lambda quantity is just 1. So is it okay, or I need to explain more elaborately?
স্যার কনস্ট্রেন্ট মানে কি?
Constraint means restriction. We have a restriction. Means okay. We need to maximize the function, but for maximizing this function, we have a restriction. The value of xy may be 2, may not be 5. This kind of restriction. So in our previous case, our restriction was the perimeter of the rectangle must be 20. So that means the values of addition of x plus y with the multiplicity 2 is equal to 20. So this is the restriction. We can put any values of x comma y in this function for maximizing this function. We need to put all of those quantities of x comma y which is satisfied this equation also. So that is our restriction. We need to choose our pair of xy values from our restriction for which our functional value is maximum. So this restriction is called the constraint.
স্যার
Is it?
কনস্ট্রেন্টসের গ্রেডিয়েন্ট কিভাবে বের করবে মানে
Okay, so now how can we calculate the gradient of this constraint? Okay, for our example, f of x comma y was something x times y, and constraint was xy is equal to x plus y minus 10. So if you forgot about the g of x comma y, so basically it was like this. Okay, we have considered, okay, our length of the rectangle is x and width is y, so we need to maximize the area. So area of this rectangle is x comma y, and our restriction was x plus y plus x plus y must be 20. So that is twice x plus twice y equal to 20. So we can write this way: x plus y is equal to 10. Just put all the quantity on the left hand side. So x plus y minus 10 equal to 0. This is called g of x comma y. So g of x comma y equal to 0, where we are considering our g of x comma y is equal to x plus y minus 10. জয়িতা, আপনি কিছু বলতে চাচ্ছেন?
জি স্যার, আমরা ডেল এক্স আর ডেল সি এটা প্যারালাল কেন ধরে নিলাম?
অ্যাকর্ডিং টু দ্য থিওরাম, আমরা এখানে ল্যাগ্রাঞ্জ মাল্টিপ্লায়ার মেথডটা এক্সপ্লেন করতেছি না, বিকজ অফ ইন ইউর ক্লাস টপিক। সো বেসিক্যালি we are interested to calculate the maximum or minimum value, that is application of Lagrange multiplier. So that's why I am not explaining the method. So I am just interested to calculate the more mathematics using the Lagrange multiplier. And according to the Lagrange multiplier, we will have the maximum quantity of the function under the restriction g of x comma y when these two quantities are parallel. Gradient of these two quantities are parallel. We can find this quantity from the theorem, that is theorem number 13.9.3. Right, sir?
Yes, sir.
Thank you. So in your class topic, so basically the included quantity is use Lagrange multiplier to calculate the optimal problem, optimization problem. So that's why our interest to calculate the optimal values. So basically getting the extreme values of a function under the restriction. So that is the more important. So for this function and restriction, our gradient of f is need to differentiate this function with respect to x. So after differentiating with respect to x, this is just y times I vector, and differentiation with respect to y is just x j vector. We can express this quantity this way also using the bracket. So first place in the bracket is basically the coefficient of I, and second place is the coefficient of j. So you can write this way also. So that is also the another vector representation, which is we can write 2i plus 3j vector this way also. This is just 2 comma 3. So this is another representation of 2i plus 3j vector. So you can write gradient of f is just simply, in this case, yi plus xj is equal to y comma x, and gradient of g is, since g is x plus y minus 10, so differentiating g with respect to x is 1, so 1i plus differentiation with respect to y is also 1, so 1 times j. We can write this way 1 comma 1. So according to the Lagrange multiplier process, Lagrange multipliers method at extreme values extreme values of the function f of x comma y under the constraint g of x comma y is equal to x plus y minus 10 equal to 0 is gradient of f is equal to lambda times gradient of g. So gradient of f, we have calculated that quantity is y comma x. So yx is equal to lambda times gradient of z is 1 comma 1. So basically 1i plus 1j. So y comma x is equal to lambda comma lambda. So basically our one vector is yi plus xj, and right hand vector is lambda I comma lambda I plus lambda I. So since these two vectors are equal, so we can write the I component and j components are equal. So we can write y is equal to lambda and also x is equal to lambda, just taking component wise equity. So in this case, for the first vector, our first quantity is y. For the second vector, first quantity is lambda. So these two quantity must be equal, since these two vectors are same. So the second quantity must be also same, because of we are just taking the equal quantity of these two vectors. So finally, we have one relation of x, y, and the lambda quantity. Since y is equal to lambda and x is equal to also lambda, so we can express, we can have a relation of x and y, and that relation is y is equal to lambda is equal to x. So that is y is equal to x. So at extremum values of function fx comma y under the given restriction, the values of x and y must be same. Just need to put this relation y is equal to x into the constraint. We will get the point of x comma y. Just put this quantity y is equal to x in the equation, in the restriction. So put y is equal to x into the constraint g of x comma y equal to 0. So our g of x comma y was x plus y minus 10 equal to 0. We can put y is equal to x in this case. So x plus x minus 10 equal to 0. So twice x minus 10 equal to 0. X is equal to 5. So since y is equal to x, so y quantity is also 5. Okay, just we have found we have calculated the point where f of x comma y has the maximum quantity. Just put x and y value in this function. Since our function was x comma y, just 5 times 5. So answer is 25. The geometric meaning of this problem is okay, we have a rectangle and the length is 5, width is also 5, and now you can see the perimeter is 20 and the area of this rectangle is 25. So this is the possible maximum area we can get when our perimeter is 20. That is, we need to choose our length and breadth equal. In that case, we can maximize that area under the given restriction of the perimeter. So I think this is clear, right? We have restriction in this case was the perimeter values are strict and that quantity is 20. But under this restriction, we need to maximize this function which is the area of this rectangle. And after using the Lagrange multiplier process, we can say maximum area of this rectangle can be 25 under the restriction of the perimeter is 20. So is it clear? Do anyone have any question on this topic?
স্যার এফ অফ এক্স ওয়াই থেকে হচ্ছে গিয়ে এক্স ওয়াই কমা এক্স এন্ড জি অফ এক্স ওয়াইটা কিভাবে পাইলাম একটু আরেকবার দেখালে ভালো ভালো হয়।
Okay, so y is equal to x, right? Okay, how we have
স্যার
calculated y
উপরের
is equal
পার্টটা
to
স্যার
x.
স্যার উপরের পার্টটা এফ অফ এক্সটা কিভাবে হচ্ছে ওয়াই কমা এক্স এন্ড এই জি অফ মানে জি ফাংশনটা কিভাবে 1,1 হলো এটা একটু।
These two quantity, right?
ইয়েস স্যার।
Okay, thank you. So our function was f of x comma y is equal to x times y. So differentiate this function with respect to x. This quantity differentiating this function with respect to x is y, and differentiation with respect to y is x. So the gradient of f is fx I vector plus fy j vector. So fx quantity is y, so times I vector, and fy is x j vector. So another representation of this vector is just this quantity y comma x. That means coefficient of I vector and coefficient of j vector. We can just use the first bracket notation. So that is also another representation of any vector. So you can write this thing or just bracket notation. And since our g of x comma y was x plus y minus 10, so differentiation this g with respect to x is just 1, and with respect to y is also 1. So that's why gradient of this g is 1 times I plus 1 times j. So another representation is just 1 comma 1. Is it clear, sir?
ওকে স্যার, থ্যাংক ইউ, আন্ডারস্টুড।
So another problem is so I'm taking problem from the exercises. So examples. So we have calculated basically this one where our p quantity was 20. So we have solved this question for the particular value of p. So you can see this question, which is example number 2, which is very similar to our example number 1. Use the Lagrange multiplier method to find the diameter of a rectangle with perimeter p and maximum area. Okay, so another example from, let's say, this one. Okay, so find the extreme values of the function f of x comma y comma z is equal to x times y times z under the constraint g of x comma y comma z is equal to x square plus y square plus z square minus 25 equal to 0. So that means we need to maximize this function, and in this case the function has three different independent variables, x, y, z, and the function is x times y times z, and constraint is now x square plus y square plus z square minus 25. So basically now the problem is restriction is three-dimensional. Okay, so for calculating the relative extrema values of the function, first of all we need to calculate the gradient of the f function, and which is fxi plus fyj plus fzk, and gradient of g, gxi, zyj, and gzk. So in this case, since we have three independent variables, so we need to use our three-dimensional gradient operator. So that's why in this case we have taken I, j, and k quantities also. So in the direction of x, y, and z. So three directional quantities are needed in this case, since our function have three different independent variables. Okay, so since our function is fxyz is x comma y comma z, that is xyz. So fx quantity is just y times z, fy is x times z, fz is x times y, and gx is twice x, zy is twice y, and zz is also 2z. So at extreme values, gradient of f is equal to lambda times gradient of g. So gradient of f is yz I vector plus xzk vector plus xyk vector is equal to lambda times gradient of z twice x I vector plus twice yz vector plus twice zk vector.
স্যার এক্স জেড জে ভেক্টর হবে না?
Xz, yes, so this is j vector, I'm sorry, this is j vector. So in the right hand side, I component is basically twice lambda x I, twice lambda yj, and twice lambda zk. Left side is yzi, xzj, and xyk. Since both vectors are equal, so component wise quantities are equal. So yz I, xz j, xyk is equal to twice x lambda I, twice y lambda j, twice z lambda k. So from this vector equation we can write yz is equal to 2 times x lambda, and xz is equal to 2 times y lambda, and xy is equal to 2 times z lambda, I'm sorry, z lambda. So from the first equation, we can write lambda is equal to yz divided by twice x. From second equation, lambda is equal to xz divided by twice y. And from the third equation, lambda is equal to xy divided by twice z. So since three quantities are lambda, so we can equate these three values. Just lambda is equal to lambda is equal to lambda. So yz divided by twice x, xz divided by twice y, xy divided by twice z. So we can multiply this total ratios by 2 so that this denominator is cancelled. First of all, taking these two ratios, yz divided by x is equal to xz divided by y. So this is basically y square z. We can cancel z from the both side, and the condition is z is not equal to 0. So let z is not equal to 0, and in that case our y square quantity is equal to x square. Now taking another two ratios, and another two ratios are, let's say, these two. You can take any two. So taking these two ratio, we can cancel x quantities. So that is xz divided by y is equal to xy divided by z. After cancelling x from the both sides, so we can write z square is equal to x square. In this case, condition is x quantity must not be 0.
Sir, y square equal to z square.
Y square is equal to z square. Sorry. So y square is equal to x square, and y square is equal to z square. So from these two equations, we can write y square is equal to x square is equal to z square. That is, at the extreme values of the given function, the x quantity, y quantity, and z quantities, square quantities of x, y, and z are basically equal. So now we have this relation, and we need to find the points on the restriction, on the constraint. So our constraint was x square plus y square plus z square minus 25 equal to 0. So at maximum point, at extreme points, the relation of x, y, z are x square is equal to y square is equal to z square. So we can use this relation in this constraint. So after putting the x and y in terms of z, or y and x in terms of z, we can replace this three variable by one. So which is just put x and y, or y and z in terms of x. That is, we can replace y square by x square. We can replace z square by x square. So after putting y square is equal to x square and z square is equal to x square, our constant is now x square plus x square plus x square minus 25 equal to 0. Since ultimately the extreme value must lie on our constraint function, so that's why this condition is putting in on the constant, and that is y square. We can use y square is something x square, and z square is also in terms of x square. So now we can calculate the values of x from this equation, and this is 3x square is equal to 25, and our x values is plus minus 5 divided by root 3. So we have calculated the x value, and since x square is equal to y square, we can also calculate the y value, and those values are also same. So y square is equal to x square is equal to 25 divided by 3. So y is also plus minus 5 divided by root 3. And z quantities also, z values are also plus minus 5 divided by root 3. So because of square quantity of x, y and z must be equal, so for the both quantities 5 divided by root 3 and minus 5 divided by root 3, square of x, y and z are basically same. So we have these points, so they have basically in this case 8 points. And why 8 points? Because of we have two choice of x value, which is 5 divided by root 3, two choice of y value 5 divided by root 3, and two choice of z value plus minus 5 divided by root 3. So these are the points where the function has extreme values, where the function have extreme values. So what is the extreme value? In this case, if we put this value in the function, since our function was fx comma y comma z is x times y times z, so we can find the maximum value when two value of x and y and z is negative, and one value is positive. So that is if we put two negative quantity 5 divided by root 3 comma 5 divided by root 3 comma one positive value 5 divided by root 3. So product of these three things is 555 divided by root 3. So this is 125 divided by 3 root 3. So another process is just need to calculate a table, and tabular process is we have 8 different points. We have 8 different points and need to put all points in the function xyz is equal to xyz. So what are the points? And point is 1, 2, 3, 4. That is all combination of the x and y and z values. So first combination may be 3 values are positive. So 5 divided by root 3, 5 divided by root 3, 5 divided by root 3. So second choice is let's say 5 divided by root 3, 5 divided by root 3, negative 5 divided by root 3. For the first choice, since our functional output is the product of three quantities, so product of three quantities for the first choice is 125 divided by 3 root 3. For the second choice, the value is 125 divided by 3 root 3 with a minus sign. So after putting all of the 8 different combinations, rest of the combinations may be 5 divided by root 3 comma 5 divided by root 3 comma 5 divided by root 3, 5 divided by root 3 comma 5 divided by root 3 comma 5 divided by root 3. In this case, considering this quantity is some negative, this is also negative, minus 5 divided by root 3, 5 divided by root 3, 5 divided by root. So we have just 8 different quantities for every choice of values of x, y and z. In that case, the values either 125 divided by 3 root 3 or minus 125 divided by 3 root 3. So that is the maximum possible values of this function. Maximum values of this function is 125 divided by 3 root 3, and the minimum value of this function is negative 125 divided by 3 root 3. So for any combinations of the points, the maximum value we can find 125 divided by 3 root 3, and the minimum value can be minus 125 divided by 3 root 3. So there may be different quantities in this case, so maybe 5 or 6 quantities. So in this case we have 8 quantities, but two values basically repeating, and the values are 125 divided by 3 root 3 and minus 125 divided by 3 root 3. So the maximum values of the functional output of all of the inputs, that quantity is called the maximum quantity of that function under the restriction, under that given restriction. And the lowest functional output is called the minimum value of that function under the given restriction g of x comma y comma z. So for this function, our function was this one, x times y times z, and restriction was, constraint was x square plus y square plus z square minus 25 equal to 0. So the functional output of this function under this restriction can be maximum 125 divided by 3 root 3. This is the maximum value, and functional output, minimum functional output under this restriction of this function can be negative 125 divided by 3 root 3. So this is the extreme values of this given function under the restriction. So we can calculate this way. This is the second example. Now, the main thing for your exam is basically you need to formulate the function and restriction and then need to solve. So this is a bit complicating, I think. Let's say for example number 3, find the points on the sphere x square plus y square plus z square equal to 36 that are closest to and farthest from the point 1, 2, 2. So this is basically so this red is a sphere, and the equation of this sphere is x square plus y square plus z square is equal to, let's say, 36. Or in this case, I have considered this as a sphere of radius 1. So for example, this is a sphere of radius 1. So this is a given point, and point is 1, 2, 2. So the question is, find the points on the sphere which is the closest from this given point 1, 2, 2, and which is farthest from this point 1, 2, 2. So this is visible. Okay, this point is something closest to this point 1, 2, 2, and this one is maybe the farthest point on a sphere from the point 1, 2, 2. So we need to find the coordinate of this point, which is the closest, and also need to find the coordinate of this point, which is the farthest point to the given point 1, 2, 2. So in this case, our restriction is, our constraint is this one. So we need to find the point from this sphere. We need to find the point from the sphere for which the points is sometimes closest to our given one or farthest to our given one. So let's say this point is x, y, z. So the closest and farthest point, coordinate of the closest and the farthest point is x, y, z. So distance of these 2 points is square root of difference of x quantity x minus 1 square, difference of y quantity y minus 2 square, and difference of z quantity z minus 2 square. This is the distance formula in 3D. So for 2D, we know this is basically x square root of x minus 1 square plus y minus 2 square. So we need to minimize this length or maximize this length under the restriction x square plus y square plus z square equal to 1. So for the simplicity, we are just removing this radical term, and that is x minus 1 square, y minus 2 square, z minus 2 square, and we need to maximize and minimize of this function, of this distance function. This is important. We need to maximize or minimize, that means we need to find the extreme values of this distance function, and those extreme values are the closest point and the farthest point. So our target is to maximize and minimize this function under the restriction of this sphere, and the restriction is x square plus y square plus z square equal to 1. So in this case, the z quantity is this one, x y z equal to x square plus y square plus z square equal to 1. We can write this way, or we can take 1 in left hand side, so negative 1 equal to 0. This is also valid. So you can write two ways of our g of x comma y comma z. One is just g of x comma y comma z is square quantities of x square, y square and z square, or you can consider 1 from the right hand side on the left side. Both are valid in this case, because of for the gradient quantity, constant is not constant doesn't have any matter. So now our question is, find the extreme value So extreme means minimum and maximum. So extreme values of function x comma y comma z. We have formulated this function, and formulated function is the distance function, which is x minus 1 square, y minus 2 square, z minus 2 square, and the restriction constraint is xyz was x square plus y square plus z square minus 1 equal to 0. So gradient of f is differentiating with respect to x is 2 times x minus 1 I, plus gradient with differentiating f with respect to y is 2 times y minus 2 j cap, and differentiation with respect to z is 2 times z minus 2 with respect to k cap, times k cap, and gradient of g is twice xi twice yj and twice zk cap. So at extreme values, our gradient of f quantity must be equal to the lambda times gradient of g. So gradient of f is 2 times x minus 1 I, 2 times y minus 2 j, 2 times z minus 2 k, lambda times twice xi twice yj twice zk.
স্যার স্কয়ার রুটটা ওভাবে জাস্ট সরায় দেওয়া গেল কেন জানি?
Square root, right? So this is okay. We can write the square root quantity in this case. If we give this square root quantity, then in this case our partial derivatives with respect to x, y, z will be bit complicated. So finding the relative maximum and minimum quantity of square root and without square root is exactly same for this both function. So that's why we are just ignoring our square root for the simplicity.
Okay, sir.
So if we give this square root quantity, then we will have some repeated quantities. So 1 divided by 2 root over these two values, and then 2x minus 1. So that is this denominator is basically, in that case, we can ignore, because of that quantity is fixed for everyone. So not need to take the square root quantity. This is enough to express the function just using without square root quantities.
So
So we
where
can
did you get the value of g of x, y, z?
g of x, y, z, how we did this quantity, right? So in this case, our point on the sphere x square plus y square plus z square is equal to 36. So that is, we need to find the points on this sphere for which distance from this particular point is farthest or closest. So we need to find the point on this sphere. So this is our restriction. This is our constraint. This is a restriction, or this is our constraint. Because of we can choose any of the values of x and y and z. We need to choose the values of x, y, z from the sphere. So that's why this is our restriction. So just I wrote it is something like this way, and I have changed bit. In this case, our right side was 1. So this is definitely not a matter. Just I did it for simplicity in that case for this graph basically. If we draw the graph of a sphere of radius 6, that is the bit bigger, and the point is just in that case inside point. So point can be inside point and outside point, that doesn't matter. But the main thing is we need to find the smallest distance and the biggest distance from this given point 1, 2, 2 on the sphere. So in this case, our restriction is we need to find the points from the sphere. So a sphere is our restriction. So that's why this is our g of x, y, z function. Is it clear, sir? We need to find the point from the sphere from this point 1, 2, 2. So we definitely can choose any point on any three-dimensional point. Let's say this one, this one, this one, this one. We can choose these points because of specific. We need to find the points on the sphere for which this point is closest to the sphere and the points farthest to the sphere. So basically we need to find this point and this point on the sphere. So since our choice is some restricted in this case, and our restriction is the equation of sphere of radius 1, so that's why this is our g quantity. So you can write this way or just this way, x square plus y square plus z square equal to 1. Both are exactly same, so not need to worry about in this case, because of for the constant quantities there is no change of the gradient values. So we can cancel two quantities from the both sides. In that case, x minus 1 times y I plus y minus 2 times j plus z minus 2 times k equal to lambda x I lambda yj lambda zk. So again we will have three different equations, and first one is x minus 1 is equal to lambda x. So lambda values is x minus 1 divided by x, and second equation we can write y minus 2 is equal to lambda y. So lambda is equal to y minus 2 divided by y, and third component z component is z minus 2 is equal to lambda z. So lambda quantity is equal to z minus 2 divided by z. So since three quantity again lambda, so we can write x minus 1 divided by x, y minus 2 divided by y, z minus 2 divided by z. So taking two ratio first two. So taking first two, thus this is x times y minus y is equal to xy minus twice x. So xy cancelled out. We can write y is equal to twice x. taking the second two ratio, y minus z divided by y minus 2 divided by y, z minus 2 divided by z. After cross multiplication, yz minus 2z is equal to yz minus twice y. So z is equal to y. So z is equal to y is equal to twice x. So that is, we can replace z by twice x. We can replace y by also twice x. So replacing all of the quantities in our constraint, since our constraint was x square plus y square plus z square minus 1 equal to 0, just put x and y values in terms of put y and z values in terms of x. So this is x square plus y square is now 4x square, and z square is also 4x square minus 1 equal to 0. So we have 9x square, and which is equal to 1. So x values is plus minus 1 divided by 3. So x values is plus minus 1 divided by 3. So for the plus values of x, plus 1 divided by 3, y is 2 divided by 3, z quantity is also 2 divided by 3. So we have one point, that is 1 divided by 3, 2 divided by 3, and 2 divided by 3. And for the negative values of x, when x quantity is negative 1 over 3, y value is negative 2 divided by 3, z value is negative 2 divided by 3. So second point is minus 1 over 3, minus 1 over 3, minus 1 over 3. Okay, now functional value f at 1 over 3, 1 over 2 over 3, and 2 over 3. I'm sorry, this is 2 over 3, 2 over 3. Square, which was x minus 1, so 1 by 3 minus 1 square. Y value is 2, 2 divided by 3 minus 2 square. 2 divided by 3 minus 2 square. So this is the closest point, and the second quantity minus 1 over 3, minus 2 over 3, minus 2 over 3. So just need to put negative 1 over 3 in the place of x, so negative 1 over 3 minus 1 square, negative 2 over 3 minus 2 square, negative 2 over 3 minus 2 square. So this quantity is bigger. I don't know what is the value ultimately after simplifying this quantity. And this one I think less quantity, so that's why this is the minimum value. That is, the closest point is this one, and the farthest point is second one. This value is the maximum value. So closest point on the sphere from the point 1, 2, 2 is 1 over 3, 2 over 3, and 2 over 3. And farthest point is negative 1 over 3, negative 2 over 3, negative 2 over 3. So we have concluded that closest and the farthest point depends on the functional value. In this case, this functional value is something less than this one. So that's why this point, since our function is defined on the distance, so functional value is less means the distance is less from the point 1, 2, 2, and functional value is bigger. That means our point is some just bigger than far distance from the given point 1, 2 to rather than the first one, which is our minimum. So you need to practice all of the problems, at least exercise problems from the section number 13.3. Sorry, 13.9.3. I'm sorry, this is 13.9, I think. Yes, 13.9 Lagrange multiplier. First of all, this is just an problem, and basically we have used the theorem number 13.9.3 for the two-dimensional two variable constraint function, and example number 1 and example number 2 are basically two variable constraint function, and this one theorem number 13.9.4, which is again constraint experiment principle, but in this case we have three different variables and one constraint, and we have just calculated this example number 3, and you need to see the example number 4 also, that is also interesting. And the practices are from section number 13.9 are from 5 to 12. So you need to do all of these practices. And in the semester, I think formulation problem is bit important. You need to see all of the formulation problems from the examples. So in this case, we have 4 different formulation and optimization problem. Optimization means we need to find the optimal values of optimal means the extreme values of the function under the restriction. So the most important from these sections are the example number 1, 2, 3, and 4. And if I have any different formulation problems, I will share all of the problems with all of you.
স্যার লাস্ট ম্যাথটার একটু দেখাতেন, কিছু জায়গা মিস
Okay,
হয়ে
so
গেছে।
yes.
স্যার একটা ইয়া ছিল স্যার, বিষয়টা স্যার আমাদের এই যেগুলো লেকচার করানো হলো স্যার, এটা পিডিএফ একটু দিয়ে দিন স্যার।
আমি অলরেডি পিডিএফ দিয়ে দিছি স্যার।
থ্যাংক ইউ স্যার।
স্যার একটা কোশ্চেন ছিল।
ইয়েস স্যার।
স্যার আপনি ম্যাথ 120 তে কোন সেকশনে ক্লাস নেন?
আমি আসলে জানি না আর কি কোন সেকশনে ক্লাস নিব, এইটুকুও জানি না যে আমি ম্যাথ 120 আদৌ নিচ্ছি কিনা। আচ্ছা, আমি আপনাদের চ্যাট বক্সেই দেই, এখানে কমন না দেই। যারা ক্লাসরুমে প্রেজেন্ট আছেন একটু কাইন্ডলি চ্যাট বক্স। So I have shared one link with all of you. So just using this link give you attendance. If any of you faces any difficulties, please let me know. This is the Google form. Just need to
request access.
Request has been denied.
Okay, so request access. I'm just seeing this one. So use second link. আমি আরো একটা লিংক পাঠাইছি, দেখেন তো এতে কাজ হয় কিনা।
স্যার এরর দেখায়,
নট পাবলিশ দেখাচ্ছে।
ওকে, সো আই এম সরি, আসলে আমার বিশেষ করে আজকে একটু অনেক বেশি প্রবলেম ফেস করতে হচ্ছে। আমি
প্রথম লিঙ্কটা মেবি রিকোয়েস্ট অ্যাকসেপ্ট করা হয়েছে, আমি কি ফিল আপ করে দিব?
ওকে, সো আমি থার্ড ওয়ান আপনাদের সাথে শেয়ার করছি, একটু কাইন্ডলি একটু দেখবেন যে এটা কাজ করে কিনা।
জি স্যার, এটা কাজ করতেছে।
ওকে, প্লিজ একটু অ্যাটেন্ডেন্স গুলো দিয়ে দিন। And I'm sorry from my end যে আমি আসলে অনেক বেশি টেকনিক্যাল প্রবলেম ফেস করছি আজকে, and আপনারা অনেক বেশি প্রবলেম ফেস করে থাকতে পারেন। আমি আমার এন্ড থেকে আম সরি যে আমাকে আরো একটু
নো প্রবলেম স্যার।
স্যার এখন তো স্যার 3টা লিংক কাজ করতেছে, তাহলে কি স্যার যে কোনো একটাতে দিলেই হবে?
এনি ওয়ানে দিলেই আমি পেয়ে যাবো আর কি। অলরেডি 13, 19 responses are received, 23 and counting goes on, 31. Nice.
স্যার লিঙ্কটা কি একটু আবার সেন্ড করা যাবে? আমার কাজ করছে না লিঙ্কটা।
শিওর। যাদের লিংক কাজ করবে না তারা একটু কাইন্ডলি আমাকে জানাবেন, আমি আলাদা করে আপনার অ্যাটেন্ডেন্সটা কল করে নেব।
তো যাদের হয়ে গেছে লিভ নিব?
Yeah, sure, you can leave.
স্যার ক্লাসটা